A maintenance worker steps onto a jammed conveyor belt to clear a mechanical fault. The power switch is flipped to the off position, but deep inside the system, a pneumatic valve holds pressure. The blockage clears, the trapped pressure releases, and the machine violently lurches back to life. To prevent industrial accidents like this, the Occupational Safety and Health Administration enforces Standard 1910.147, commonly known as Lockout Tagout. We have built a 10-question compliance gauntlet based on these regulations. Grab a pen and keep track of your score to see if your safety knowledge holds up against federal standards. Before we begin, we need to clarify two roles. OSHA defines an authorized employee as the person who physically applies the lock and performs the maintenance. An affected employee is someone whose job requires them to operate that machine or simply work in the surrounding area. Confusing these two classifications leads to severe injuries. An affected employee might know how to run the equipment, but they do not have the training to isolate its power sources. The person turning the wrench must be the authorized employee holding the key to the lock. Let's start the gauntlet. Question 1. You are about to service a jammed machine. Does pushing the emergency stop button safely isolate the equipment for maintenance? The answer is no. E-stops and push buttons are control circuits. They send a signal to stop the machine, but they do not physically break the flow of electricity. OSHA requires the use of an energy isolating device, like a manual circuit breaker or a disconnect switch, which creates a physical air gap in the power feed. Question 2. You successfully lock out the main electrical breaker. Why would opening a hydraulic line release 2,000 psi of dangerous fluid? This 3D diagram shows the answer, skipping the release of stored energy. Shutting off the main power does not instantly neutralize a machine. Hazardous energy remains trapped in compressed springs, elevated gravity components, and pressurized hydraulic lines. You must actively block, restrain, or bleed down that residual pressure to zero. Question 3. You have locked the breaker and bled all the hydraulic lines. What is the absolute final physical action required before you safely place your hands into the machine's danger zone? The answer is the try-start verification. You must return to the control panel and actively attempt to turn the machine on. Pushing the start button and watching the equipment fail to respond proves that you identified the correct breaker, that the switch functioned properly, and that the isolation is completely successful. Question 4. You test an electrical circuit with a multimeter and the screen reads 0 volts. Why are you still not legally safe to begin work under Standard 1910.333? This flowchart illustrates the live-dead-live method. A broken multimeter or a free test lead will read 0 volts, even when touching a live wire. To prevent a false negative, test a known live source, test your target circuit, and test the live source again. That final test proves your equipment did not malfunction during the procedure. Only then can you trust the dead reading. Question 5. You encounter an older breaker that physically cannot accept a padlock. If you are forced to use a tagout device, a warning tag, what legal standard must you demonstrate to OSHA? The answer is full employee protection. A tag is essentially just a warning sign. To legally substitute it for a lock, you must implement additional safety measures that provide the exact same level of physical security. This means doing things like removing a valve handle entirely or physically extracting a critical isolating circuit element. Treating warning tags with default trust, or assuming invisible electrical energy is gone just because a switch is flipped, removes your physical barriers to hazard. Question 6. You have 5 different mechanics assigned to overhaul a single massive industrial press. How do they securely lock out the machine without overriding each other's safety? This diagram shows a group lockbox protocol. A primary authorized employee applies a single lock to the machine's main energy source and places the key inside this box. Then, each of the 5 mechanics applies their own personal padlock to the outside of the box. The machine cannot be re-energized until every single worker finishes their task and removes their specific lock. Question 7. Shift A ends at 5 p.m., but the machine is still broken. How is the lockout transferred to arriving mechanics on Shift B? This timeline graphic maps out the orderly transfer rule. The protection must be continuous. Shift A cannot remove their lock at 4:55 and leave the machine unprotected until Shift B arrives at 5:05. Facility procedures must ensure an exact overlap. Often, this involves Shift B applying their lock to the hasp before Shift A removes theirs, or utilizing a standardized transfer lock system that maintains the isolation barrier. Uncoordinated human handoffs and assumptions about who is controlling the equipment are the weakest links in maintaining a zero-energy state. Question 8. An authorized employee goes home with their personal lock still attached to a machine and is completely unreachable. Under what strict conditions can a supervisor cut that lock? The employer must document their verification that the employee has physically left the facility, and they must exhaust all reasonable efforts to contact them. Crucially, they must ensure the employee is informed that their lock was removed before they are allowed to resume work on their next shift. Question 9. An outside electrical contractor arrives to service your facility. Who is legally required to inform whom about their respective lockout procedures? The standard requires both parties to share their procedures. The on-site employer and the outside contractor must brief each other so that facility staff recognize the contractor's locks and the contractor understands the facility's specific energy controls. Question 10. Under what extremely narrow circumstance does OSHA legally permit working on live, exposed electrical parts? Live work is only justified if de-energizing the equipment introduces a greater hazard, such as shutting down a hospital life support system, or if it is technically infeasible to perform the required diagnostic testing without power. Bypassing safety protocols for speed or convenience is never a valid justification. Doing so transforms a controlled maintenance task into a lethal gamble. Tally up your final score. If you scored under an 8, you have critical vulnerabilities in how you approach hazardous energy. This 6-step flowchart outlines the 1910.147 requirements for immediate application on the shop floor. Step 1. Prepare for shutdown. Step 2. Shut down the equipment. Step 3. Isolate all energy sources. Step 4. Apply lockout or tagout devices. Step 5. Release all stored energy. And Step 6. Verify the isolation. That final step, verification, is the ultimate barrier between a routine task and a fatal accident. Whether attempting a try-start on a mechanical press or performing a live-dead live test on an electrical panel, you must prove the energy is gone. Drop your score out of 10 in the comments below to see how your hazard awareness compares to your peers in the industry. Surviving industrial maintenance requires systematic proof. You cannot trust the equipment, and you cannot assume a system is dead. You have to verify the absence of hazardous energy every single time. Subscribe to the channel for more breakdowns on HSE compliance and safety engineering.